In this video, I will be solving this ODE right here via the undetermined coefficients method. So first, we will write out the ODE right here, and what we want to do is we want to find a complementary equation where the system is homogeneous. So first, what I'll do right here is we'll have our left-hand side, and we'll set it equal to 0. So the system is homogeneous. And we can solve this equation to get a solution to the complementary, because we know that the set of solutions for this ODE right here will be equal to the solutions to the complementary equation plus the solutions to the particular equation, where we take into account the right-hand side of this ODE. Okay, so first off, we'll set up our characteristic equation for this complementary. We'll have r squared plus 4, and just, from algebra I can see this will have a complex solution. Okay, so I'll go and write it out right here, and we see from the quadratic formula we can set this up, and we have 0 plus or minus the square root of -16. Okay, so we'll have a -1, that'll give us I with this square root. And then 16 will simplify to 4. We have a 2 on the bottom, so we can divide that. And we'll get r is equal to 2i or -2i. So those will be our two roots. And because we know this is complex, we can use our knowledge of second order homogeneous equations. We know the three cases for our solutions. We know this is complex, so we'll have something like, we'll have y equals e to the at, and then we'll have times c sub 1 cosine dt plus c sub 2 sine dt. So that'll be the form of y of c. Okay, so we'll have c sub 1 cosine 2t. We have b right here and a right here. Let me write that out. Okay, just to show. So our solution is of the form of a plus minus bi. Okay, and this is our imaginary part, real part. So we'll have c sub 1 and so on and so forth on our right-hand side equal to the complementary solutions. So whenever we're setting up our particular solution, okay, we're going to use the right-hand side. So we want complementary solutions to look like this, okay? Because we know that these will have this set of our solutions for this equation. So what we're going to do, we're going to set up, we want y sub p to look like this, a sine 2t plus b cosine 2t. However, we can see that this matches the form of y sub c. We're just replacing our variables in this case. So how can we avoid what we would get right here, a trivial solution? Because you can see that if we plug this in, we have the second derivative of this term, okay, and we can see right here, we'll get 4, and then these will cycle, so we'll have a -4, a -4, we'll take it out, and you'll see that these two cancel. We'll get y particular is equal to 0, a trivial solution, and this happens for all differential equations. So we're going to need to find something else. Now what we can see here is that for our complementary equation, this is a homogeneous system. So we can use that same kind of solution, and the reasoning is we will multiply both sides by t, okay, and this side will equal 0, and this side can still have that t, okay. So we'll use that same kind of solution, and we'll multiply y particular by t on both sides, knowing that this is going to equal 0 for solutions. Okay, make the ODE become 0. That's a better way to put it. Okay, so we multiply by t, and we want to get this form right here. We want to get this form. So what we'll do is we'll take each of the derivatives up to the second. Okay, right here we use the chain rule. We use the chain rule again, and notice for this one we're using 4 y sub p, so we can multiply this by 4, and then we're adding it into y double prime, y sub p double prime. Okay, so we have this term, and then this is negative 4 times t, same kind of thing. So this is basically, this is going to cancel out with this right here, okay? So we add these two together, and we're going to get on the outside of 4, and then we're going to have a times cosine 2t minus b sine 2t, okay? And then we know that we want these to equal out with our original ODE. What we had over here is f of t, okay? So we could say the right-hand side is f of t. We're going to get that to try to equal, so we can have a zero solution, okay? So we don't even have to, like, right here, we can just look at the coefficients and match things up. So we can group the sines, and then we can group the cosines, okay? And then you can kind of mark them out right here. So this is the only important part. Negative 4b equal to 11. So we'll get b is equal to negative 11 divided by 4. We can cancel out the signs. 4a equal to, we would have a 1 right here. So a is equal to 1/4. So for our general solution in total, we know that our general solution for the whole entire ODE, taking into account both the particular solution and solutions to the complementary equation, we'll have y is equal to y sub p plus y sub c. This is a set of all of those solutions, okay? So we'll do the same thing right here, and we get our general solution. And we're just plugging in a and b that we found for this equation.